Alrighty, another leak code today. Leak code 2192. All ancestors have a node and a directed acyclic graph. You're given a positive integer n representing the number directed a DAG. The nodes are numbered from 0 to n minus 1. You are also given a 2D integer array edges where the notes that there is an unidirectional edge from that to... Okay, so it's direct. Okay, that's pretty standard. Return So I mean, this is a graph problem, graph traversal. And we want to get all the ancestors, and ancestors just what? Any... Right. If you can reach this, and since there's no cycles or... Yeah, there's no cycles, then we should be pretty chill, right? We just start from the top and try to go down. So I think topological sort, and then Kahn's algorithm, because I like Kahn's algorithm. So let's just initialize the adjacency list. This is my favorite way to initialize an adjacency list. I think it's the most efficient if you know how many nodes there are. And you know what, while we're at it, we might as well say this integer res equal to new array list, and then we could say that we just say res.add new array list. Yes. So we initialize our adjacency list like this. Awesome sauce. And then let's just construct our graph. And edge and edges. And ooh, for topological sort we need in degree. Right? So let's say that adjacency of edge 0 dot add edge 1, and it is directed, so we don't need to do the other side. And then we'll say in degree of edge 1 plus plus. And with Kahn's algorithm, we'll use a queue, and we'll start from nodes with 0 in degrees, so 0, 1, and 2, and then perform a BFS, right? Oh! Does it matter? Ooh, sorted in ascending order. Ah, that's annoying. Ew. That's gross. I'll figure it out later. Equal new linked list. So for int I equals 0, I is less than n, I plus plus. If in degree I is equal to 0, q dot offer I, and then we'll say while so while q dot is empty, I'm gonna say int cur is equal to q dot pull. Oh. Ooh, wait, but what if... Interesting. Okay, how about this? Instead of like actually dealing with this, let's have a int. How big is n, by the way? Please don't be humongous. 1000. That's manageable. Int well, not even int, it would just be boolean ancestor. Boolean n by n. Pew pew pew. Okay. And then we'll just say, how do I remember Khan's algorithm? So we'll queue the current pool, and then we'll say for int, just let's call this u actually, because I like the word. So for int v in adjacency u, we'll say for int I equals 0, I is less than n, I plus plus. If ancestor u, then we'll say ancestor v is equal to true. Right. That makes sense. And then if minus minus in degree of v is equal to 0, then q dot offer v. And then we'll say for int I equals 0, I is less than n, I plus plus. For int j equals 0, j is less than n, j plus plus. If ancestor I, then res.get j.add. Oh, wait, if ancestor j res.get I.add j. Maybe this will work, who knows? Oh. 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 Ooh, that's a good point. If ancestor u of I, v of I, duh. If ancestor I of j, there we go. Okay. What the flip? Am I stupid? It is also empty over here. Okay. What's probably happening is the entire thing is this makes sense. Oh, okay. Great. Okay, wait a minute. We need to say ancestor of v to u is equal to true. Okay, so that works. Now will it pass? Hey, and we did not do that bad time, even though we have like some ridiculous for loops in here. So just to take it from the top, we're gonna, well, literally, we just start with these nodes here, and we just kind of fill from the bottom, because this is an acyclic directed graph, so it makes sense to start with nodes with no ancestors, and then just fill that. Just keep filling that to the bottom, and we just kind of process that all at the end. Yay. How long did that take? 10 minutes! It's pretty good.